Hi everybody, it's Mrs. Dunn. We're about to start my two favorite sections in this college algebra course. So what we're going to be doing first is we're going to be talking about polynomial division in this screencast. You're going to divide polynomials, you're going to use synthetic division to divide polynomials, and then we're going to learn about the remainder theorem and the factor theorem, and we're going to use those. So what I want to do is I want to go back and I want to talk about a couple of things that we've learned in previous screencasts. So you remember we've been talking for quite a while here about polynomial functions. And you know that this polynomial function may be factored. And this one actually does factor into x plus 3 times x plus 1 and times x minus 2. So the factors are exactly that, x plus 3, x plus 1, and x minus 2. And if those are the factors of the polynomial function, then what are the zeros? Well, the zeros are negative 3, negative 1, and 2. Okay, so think about that. If we know the factors, we can find the zeros. And if we know the zeros, we can find the factors. That's a lot of what we're going to be covering today. Okay, so let me give you a specific example of this new material where we're going to be doing division to determine if something is a factor. So, for example, is x plus 1 a factor of x cubed plus 2x squared minus 5x minus 6? Well, think about how we determine if something is a factor. Like if I asked you, is 2 a factor of 24? Well, yes, it is. And it is a factor because you can divide 2 into 24 and there's no remainder. It's the same thing in algebra. If we divide x cubed plus 2x squared minus 5x minus 6 by x plus 1, and there's no remainder, which is the same as the remainder being 0, then it is a factor. So that's what we're going to do. All right, so we're going to put x cubed plus 2x squared minus 5x minus 6 in the box, and we're dividing by x plus 1. Now what we're going to do is we're going to put here that number that when I multiply it by x, I end up with x cubed. So what times x will give me x cubed? Did you guess x squared? X squared times x will give me x cubed. So what I do is I take this x squared and I multiply it by x and by 1. So we have x cubed plus x squared. And then just like in long division, when you're doing it with numbers, if you ever do it with numbers anymore and don't use your calculator, I'm going to subtract this from x cubed plus 2x squared. So x cubed minus x cubed is 0. And 2x squared minus x squared is x squared. And now in the next step, just like in long division, I'm going to bring down the next term. Now you have to start the process over again. What should I multiply x by to get x squared? Well, I should multiply by x. Now when I multiply by x, x times x is x squared. X times 1 is x. Just like before, I'm going to subtract that. X squared minus x squared is 0. And negative 5x minus x, remember I'm subtracting, is going to give me a negative 6x. And then I bring down the next term. Now, what do I multiply by? X to get negative 6x. Well, I should multiply by negative 6. So when I multiply by negative 6, I get negative 6x minus 6. And in my last step, I'm going to subtract that, and I get a remainder of 0. So 0 is my remainder. And since the remainder is 0, we know x plus 1 is a factor of x cubed plus 2x squared minus 5x minus 6. Now, if x plus 1 is a factor, then remember -1 is a 0. Just hold on to that thought. There's a couple other things that I want to show you here on this screen. So 0 is the remainder in this long division problem. I want to talk to you about some other terms. So on top of the fraction, or on top of the division bar, we have x squared plus x minus 6. That's called our quotient. What's under that division bar is called our dividend. And what we divide by is called the divisor. Just want to make sure all those words make sense to you when you see them in your homework or if you're reading the textbook. Okay, so 4 new terms there: remainder, quotient, dividend, and divisor. Okay, next thing. Is x minus 3 a factor of x cubed plus 2x squared minus 5x minus 6? Remember from the last example, if we divide x cubed plus 2x squared minus 5x minus 6 by x minus 3, and the remainder is 0, then it is a factor. I would like you to try this. So I showed you how to do the division. I want you to try it. And hopefully you got this as your answer. So you should have gotten a remainder of 24. Since the remainder is 24 and not 0, then x minus 3 is not a factor. Just a little bit with the terminology. So the quotient, which you're going to see in your assignments, we call q of x. The quotient is x squared plus 5x plus 10. And the remainder, which we call r of x, is 24. Okay, now, I want to show you another way to do division. So we just learned long division, but you could actually do something called synthetic division. So we're going to do synthetic division first, or next, sorry. So I have this example next to us so that you can see how it's similar. So when you do synthetic division, notice if I'm dividing this polynomial by x minus 3, it's the 0 that I divide by. So if x minus 3 is a factor, 3 would be the 0. So I'm doing the opposite of this sign, positive 3. Notice I'm writing down the coefficients, not the actual terms, but the coefficients. The coefficient of x cubed is 1, of x squared is 2, of x is -5, and the constant is -6. And I'm going to write these down. So here's the process. I bring down the first term, and then I'm going to multiply 3 times 1 and put that answer here. And then I'm going to add these two terms together. So 2 plus 3 is 5. And then I'm going to multiply 3 times 5 again, which gives me 3 times 5 gives me positive 15. And then I'm going to add these two terms together, which gives me 10. And then multiply again, 3 times 10 equals 30, and add these together, and I get 24. So look at what I got. So I did the same thing. I feel like it's a lot easier. And I got the same remainder of 24. So that last number, I always put it in a box to separate it from the rest, and I'll show you why in a second. So that last number, 24, is the remainder. I just wanted to point out it's the same remainder we got with long division. But look at these other numbers. Do they look familiar to you? So those numbers are the coefficients of the quotient. Isn't that cool? So x squared plus 5x plus 10 is the quotient. So the quotient is x squared plus 5x plus 10, and the remainder is 24, all from this synthetic division. See, every time we do this division, we're lowering the exponent by 1. We started with a cubic equation, so our quotient is going to be quadratic, third degree and then second degree. All right, I'm going to give you a chance to try this with the next question. So use synthetic division to find the quotient and the remainder for 2x cubed plus 7x squared minus 5 divided by x plus 3. Before you do this, I want to caution you. Remember, since this says x plus 3, we're dividing by -3, so make sure it's -3 that you put here. And the coefficients are 2, 7, and notice there's no x term. I need to show that in my long division and in synthetic division. So I put a 0 there to indicate there's no x term, and then -5. See, it should go 3, 2, the 1 is missing, that's why we use a 0, and -5. All right, now you try the synthetic division. Hopefully you got 4 as your remainder. So the quotient is, remember we started with a cubic, so our quotient's going to be quadratic. So it's 2x squared plus x minus 3 is the quotient, and the remainder is 4. All right, I'm going to stay here for a minute because I want to show you something. So check this out. If we say f of x is 2x cubed plus 7x squared minus 5, I want you to find f of -3. Pause the screencast, plug it in your calculator, plug -3 into that equation, and what did you get as your answer? Did you get 4? Does 4 look familiar? Yes. Isn't it so cool that the value of the function is equal to the remainder? The value of the function at -3 is equal to the remainder when you do the division. That's actually a theorem, and it's pretty cool. So the remainder theorem says that if a number c is substituted for x in the polynomial of f of x, then the result, which we call f of c, is the remainder that we would get if we divided f of x by x minus c. It's really pretty cool. And we can use that idea to determine whether a number is a 0 of a function. So for example, determine whether 5 is a 0 of g of x, where g of x is this formula, x to the 4th minus 26x squared plus 25. To determine that, we're going to do synthetic division. Don't forget to substitute a 0 for the x cubed term and the x term. So the synthetic division looks like this, and our remainder is 0. Since the remainder is 0, g of 5 is equal to 0, and 5 is a 0 of g of x. All right, getting a lot done in this screencast. So now we're going to go back to that screen. This was the first screen in this screencast where I was talking about putting things together, where if we knew the factors, we know the zeros, and if we know the zeros, then we know the factors. So we talked about this already. This actually also has a name. It's short and sweet, and it's called the factor theorem. So for any polynomial f of x, if f of c is equal to 0, then x minus c is a factor of f of x. All right, so let's put all this to work. So here we have this polynomial function, f of x, and it's equal to x cubed plus 4x squared plus x minus 6. I have to factor this polynomial and solve the equation f of x equals 0, which is the same as finding the zeros of the function. Well, you can't factor this by grouping because it's not going to work. You're not going to get the same thing in the parentheses. So how are we going to solve this? Well, take out your calculator and graph it. So graph that function. That helps. So you can see it actually does have 3 zeros. It has the shape we would expect. Now, go to the table like I showed you in a previous screencast and look at the table. And what we're looking for are the zeros. So what values give us 0? This is a nice example because we see them. It happens at -3, -2, and at 1. Those are the zeros of our function. So we have zeros at -3, -2, and 1. Okay, if you know the zeros, what are the factors? So the factors are x plus 3, x plus 2, and x minus 1. And put that together. F of x equals x plus 3 times x plus 2 times x minus 1. Isn't that cool? All right, now in our table. So that's what's going to happen next time. Good luck. Email me with your questions.